Understanding IP and file-based technology. Current IP media practices. Professional media environments provide multiple means for moving video, compressed files or streaming media, across the campus, between cities, etc. The audio-video is transported in a compressed format of different kinds. Some are highly compressed for internet delivery and others are mildly compressed. However, there are few means to transport uncompressed, high bitrate, HBR, content end-to-end over the network. We'll focus on the latest applications for high bandwidth, real-time, live broadcast production using IP over a media-centric network. High bitrate uncompressed video transport. Internet Protocol, IP, network technologies are already in use at many media facilities for live real-time production activities. Due to the recent SMPTE standards and initiatives, broadcast production is beginning to use new capabilities for transport and manipulation of high bitrate, uncompressed, UC, signals over an IP network topology. The approaches are applicable to file-based workflows, data migration, storage and archive, automation and facility command and control. Rules of engagement. IT changes everything. IP is a set of rules, protocols, which govern the format of the data sent over the Internet. For broadcast or studio facilities, Internet is more appropriately called the network. Designing and building an IP facility require a renewed technological approach to it networking compared to those for traditional SDI facilities. One key target in this will be to keep audio and video, over IP networks, acting precisely the way it does in an SDI world without its burdens or constraints. Where are the differences? The isochronous, time-bounded, nature of SDI, born out of the 1980s standards, is straightforward for live, continuous video inside the studio and for long-distance transport. Frame-accurate, undisturbed, transitions with a compressed video are generally accomplished using the peripheral equipment. It receives a compressed video, then decompresses it to a baseband, SDI, form, where then transitions from A source to B source are completed. These processes take time and it is impractical for most live applications to cleanly switch sources and maintain timing and synchronization. Program videos on YouTube or Netflix leverage receiver buffering techniques or use adaptive bitrate, abridged, streaming functions to keep their linear delivery as seamless as possible to viewers. For professional media IP systems, real-time live signals, on a network, are transported over isolated, secondary or virtual networks, VLANs. For live and real-time, HBR signal transport, new network topology and timing rules, protocols, must be adhered to. They are defined in the new standards SMPTE ST2110 and or ST2022. Differing data traffic structures. Packet structure and formatting is different per each data type's intended uses. Different data traffic types are not mixed on the same VLAN network. Real-time transport networks are conditioned to carry HBR traffic. Packets from senders, transmitters, are constructed based on IETF RFCs such as Real-Time Transport Protocols, RTP, and Session Description Protocols, SDP, and supporting IEEE and SMPTE standards. The other conditions identified in the SMPTE ST2110 or ST2022 standards are timing, synchronization, latency, and flow control. File-based and streaming media is intended to, or can run at variable data rates, while previous IT-like network designs must run continuously at non-wavering data bit rates. In file-based transport, data from senders need not arrive at receiver input, S, in an isochronous nature. In streaming media delivery, occasional interruptions or buffering is expected, while live real-time video must be synchronously time-aligned. That is why system designs now include distinct considerations for real-time and non-real-time signal flows.